me today with my colleague Keith. Now if you're new to motion amplification, I really recommend you check out the video in the link below first. So this video is all about updating you on the benefits we've had using this technology, which has been developed by RDI in the US. Over the last year, we've had some fantastic updates with this system, the Iris M, and we're going to go through those with you today. So Keith, we've used this technology intensively over the last year. Where do you think we've had like the most benefit and applications for using it?
Well, we've used it on a range of applications, from rotating equipment to pipework surveys. We've done structural vibration on buildings, all sorts of different things like that. The range of applications just keeps growing, I think.
Yeah. And where, on some of those applications, let's take rotating equipment, where do you see the big benefit with it, with rotating plant? Because we've all got vibration analyzers.
Yeah, it's true. Well, we fitted it in to our normal root vibration. So where we've been around doing our root measurements and we found high levels, the camera's great to just go and quickly put it against our machine and find out what the root cause is.
Yeah.
So we've got this phase now, we just get the camera out. We don't bother going in trying to do cross-channel phase and all that kind of stuff. There's no point because it's so quick.
Yeah, and you've got the 2.3 million sensors. So really on bases, and I've obviously done a lot of videos with you, for me, it really does excel on those bases, doesn't it?
Yeah, I'd say so. We've had some wicked bass problems we've found with it.
Yeah.
We've done some, just recently we've had some pipework problems that's damaged the bass and you can really see it.
Yeah.
We've had problems where the structure of the bass is weak.
Yeah.
So you get that structural weakness.
Yeah.
We've seen loose bolts. We've seen all sorts of problems on basses.
Yeah.
Any bass problem, the camera just excels in that.
I mean, the thing is as well, it can be used just as a troubleshoot tool where you get a job and someone says, can you come and have a look at this? And it's worked well with that, hasn't it? And we've done a lot of that with pipe work, and I feel that's worked quite well. But what about the frequency range? You did some high frequency recently on some pipe work, right?
Yeah, so we found one of the areas we could push it in the camera was looking at high frequency vibration.
Yeah.
And the reason for that is it measures in displacement.
Yeah.
So it's really favourable in low frequency. So we wanted to see how high we could go with it.
Yeah.
And so we've got some really good shots on a power turbine where they had high casing levels.
Yeah.
And we thought, well, let's go and have a look around that bearing, and there was leaking oil.
Yeah.
So we put the camera on it, just a quick scan.
Yeah.
And at 7,500 RPM, this machine runs at. We found a crack in the weld, and it really highlighted.
That's brilliant. And interestingly, I did a job. I got asked to look at a deaerator vessel on a CHP plant, and I remember that showed. I think it was around 1 hertz.
Yeah.
It was vibrating out, absolutely fantastic, and the camera excelled on that. So yeah, another benefit with a camera is you can really use it for commissioning and verification, and sort of just doing scans maybe when you don't even know there's a problem there. We've had quite a lot of success with that. And I remember that cooling water one, that was quite good, wasn't it?
Yeah, it was awesome, really blew us away, I think. The client just asked us to go and have a quick scan. We've had a few problems, we just want to have a overview of the machinery.
Yeah.
So it's a load of pumps, and we managed to just pick out one that had a really bad bass problem, and it was caused by this flow vibration, which we never picked up on our normal root vibration, but because it's all in low frequency displacement, but the camera just excelled on that. So
it's a fair point that, Keith, because generally on his roots we're looking in velocity and obviously acceleration for bearings. We're not doing routine displacement measurements. And on that job, I've seen the data you showed me it. It was amazing that, like you say, it wasn't really picked up on the root, but with the camera, because it's a displacement visualization tool, it really nailed it.
Yeah, so I think seeing it as a routine scanning tool as well is becoming more apparent for that.
Yeah, no, definitely. I think for me though, one of the biggest things with the camera technology where it was a bit of a surprise was using it as a communication tool. I didn't realise the impact that was going to have, because we're vibration guys, we're talking 1 times, 2 times, but when we've been showing these videos, the response we've got has been phenomenal, hasn't it? On some of these bass problems and that, it really gets the point across, and for me that's probably one of the biggest benefits with this camera.
I think so, yeah. A lot of the users have said to us, like feedback, they've said that it's made their job a lot easier. Instead of showing graphs and squiggles, they're able to just show a video to their colleagues and get the message across very easily. Yeah.
I mean, this is a bit odd, but I've actually found, and some of my clients, that they seem actually more willing to complete the job and rectify it, because when they see it, they understand it. And I think, we take that for granted as VA guys. Yeah, it's a fantastic system for sure.
Yeah.
Well, what we're going to do now, we're going to have a little chat, we might move, and we might talk about some other updates with the camera system. Over the last year, there's been some fantastic updates to the Iris M system. The first one was the frequency displacement module. Keith, you've got a vibration analyzer. What benefit is having this capability within this system?
Oh, well, it's fantastic really, because we can take non-contact measurements with the camera. We've got that visual aspect, but the fact that we can take non-contact measurements anywhere in that image is really powerful.
So stuff like, let's say this pipe work behind us, you could easily get accurate readings off there?
Yeah, we could literally turn the camera right now, get some shots, and we'd able to just pick out along the pipework measurement points that we wanted. So we could measure deflection along the whole pipework you can see there. So we could take 10, 20, 30 readings.
So how accurate is it? Is it as accurate as if I went up there and put an Excel on?
Yeah, it's the same as having an accelerometer, it's spot on.
But we have to set the distance, I assume we have to tell the system.
Yeah, there's a bit of a setup with that, so you need to put points on there and take the measurements for those points, so you always get the right amplitude. The frequency is always correct when you take the measurement.
And what about if we were doing, say, a typical pump where I can get access with my analyzer? Can you do phase, anything like that?
Yeah, well, that's another really good thing about using the frequency displacement measurements, is that we can see the time waveform, so we can go right next to a coupling and shoot over the coupling, take the drive end of the motor, drive end of the pump or whatever it is, and we can take the waveforms, overlay them and see the phase relationship.
All right, and that's because all the videos starting from one position, we don't need obviously a tacho.
That's it.
It's all to do with referencing against each other.
Exactly.
Okay, cool. I think one of the things I think the real benefit is if you go and collect some data on site, you can get back to the office and then I guess just keep taking vibration readings wherever you want on the video image.
Yeah, exactly. Yeah, it's quite funny actually, because you always see more when you go and sit in the office, don't you, and sit down, have a cup of coffee and have a play then.
But really then with this system, I suppose we're talking about, there's two systems really. There's a visual aspect and then there's this frequency side. So you can use both, or I guess either or really.
Yeah, it doesn't require you to have a vibration background, but a vibration analyst can use it in that way if they need to. So you need that engineering background, use that visual side of it.
And what about frequency ranges? How do we adjust that? I guess we can look at some high frequencies and low frequencies.
Yeah, so our F-max at the moment is up to 650 hertz.
Okay.
It really excels at the lower frequencies, so we go from 0 upwards.
Okay. All right. And what if I wanted to take a higher resolution spectrum with a camera? How would I do that?
Oh, it's simple. You just take a longer reading. See, a lot of our readings you see were about 3 to 6 seconds, but we still see the peaks. But if we wanted to get a real defined peak in there, split some peaks up, we can just take a longer reading.
So I hope that gives you a bit of an overview of the frequency displacement module. And like I say, it's a great tool, and just get out there and use it. So one of the updates I was really looking forward to was filtering, and it didn't disappoint, did it, Keith?
No, it's brilliant.
Can you just tell me a bit about it and how it works?
So really simple. What it allows you to do is to say, in this video, just show me what X frequency is doing, or Y frequency or Z frequency, so that you can filter out frequencies that you don't want to see in the video.
Okay, yeah. And that, I'm guessing on something like a fan, where you've got, say, a motor frequency, fan's running at a different speed. If you just want to see the motion from the fan, we can isolate that.
Yeah.
And that's using applying the filters, is it?
Yeah, so you take your spectrum normally, you can see then the frequency peaks, and then it's a really easy to use system where you can just put your filters, band passes, band stop, high pass, low pass, and you put those around the peaks that you want to see or exclude, process the video again, and you've got another new video just how you wanted it.
Yeah, no, it's fantastic. I've used it so much, and one of the examples I remember was at the where we had these shaker screens, and they got some cracked pipe work, cracked duct work, and we actually isolated one of the frequencies on this pipe and just looked at the motion, and we could see that was the problem for everything else. It made it so simple, and again, showing it to the customer, very visual.
That was a really good one. You could see two different speeds of screens as well in there, shaker screens, and you could filter out one so it stopped all together, and then filter out another one. You could see the effect that each one was having on the pipework.
Yeah, I remember that. And you've done some stuff on alternators with different modes of vibration and that?
Yeah, so for the likes of reciprocating machines, it's really good to see what the different frequencies is affecting. You can see how the firing frequencies on a recip, for example, or you can see the AV mounts, how they're working. Really good for that kind of thing.
Another benefit we've had with this filtering is we know the camera has to be stable, but we can't guarantee that every time. So we've been on unstable floors. It's been absolutely brilliant for that.
That was a bit of a surprise, really, wasn't it?
Yeah. So if it's at a different frequency to what we're looking at, we can filter out that vibration, can't we?
Yeah, exactly. So if we're looking at a machine that's vibrating at a certain frequency, and we're at the one next to it, which runs at a different speed, and the floor vibrates, we can just move to that machine and film back at the one we want to see, and then we just filter out the frequency of our movement.
So what would you do then in a situation where what you're looking at, the frequency is the same as what the floor's vibrating? How would you get around that though?
So in that case, well, you do get some floor vibration, and you can filter it, but then we've got a really nice bit in the software we can stabilise it as well.
Yeah, I've used that before.
Yeah, so you just make sure that you get a shot with something in the background you can stabilise too, and you can stabilise that.
Yeah. No, I think that's a good summary of the filtering. We use it all the time, and your insight into machines is just unbelievable. In the last year, I've been viewing machines now totally different to what I originally did. It really is an awesome tool. So the latest update to the system is the Motion Explorer, which is basically a file management system of all the videos and that, and I think it really rounds this system off. Keith, you want to just chat and just tell us a bit more about it?
Yeah, well, it's actually a whole new piece of software that comes with the system. So it's quite a big update, really. What it does is it aggregates all your data, so you're able to create a hierarchy of all your assets, all your different points where you take measurements from, and then you can store videos to that. You can launch new acquisitions with the same settings for that asset itself. You can also put in JPEGs in there. You can put reports to each individual asset, so you can keep track of those things.
So if I've got, like on a site like this, I can sort of build areas, machines, and basically assign it, a bit like a vibration database.
Exactly like that, yeah.
So yeah, we really like the Motion Explorer. Like I said, it really rounds the system off. If you want to get a bit more detail, if you watch the video shortly after this, you'll get a real feel for what it can do.